Today's lesson is word problems using vectors. My learning objective is I can find the magnitude and direction of the resultant vectors to solve real-life application problems by applying the parallelogram or oblique triangle method or the vector method. If we're using the parallel method or the oblique triangle method, we're going to use the law of cosines and law of sines. If I'm going to use the vector method, I'm going to use the formulas for x, y, r, and theta. All right, let's start out with the first example is two forces of 20 newtons and 10 newtons are pulling at an object of 0 and minus 30 degrees with respect to the x-axis. Draw the resultant vector and use trigonometry to find the magnitude to 3 decimal places and direction to the nearest degree of the x-axis with respect to the x-axis. Okay. So let's draw a diagram of this first to understand this. All right, here we go. So I have one force that is 20 newtons at 0 degrees. So 20 newtons at 0 degrees. So we're talking with the x-axis, so this would be geometry. So this would be 20 degrees with the x-axis, or 20 newtons. So here's 20 newtons at 0 degrees and 10 newtons at minus 30 degrees. So here's 10 newtons. I guess they don't have to be drawn to scale. So minus 30 degrees. So to use the parallelogram method, I'm going to draw tip to tail. So I'm going to make this one 10 newtons, or I could say this one 20 newtons. So if I draw both of them, I form a parallelogram now. So my resultant vector is going to be from here to here. So this is my resultant vector. Okay. So I want to solve for the resultant vector here, and then I want to know this angle here. So to do that, I'm going to work with this oblique triangle. Okay, so with the oblique triangle, what I'm going to do is I need to solve for the resultant. So that would be the third side. So I'm going to use the law of cosines. So to find a side, I take the other two sides squared minus 2 times each side and the cosine of the included angle. Okay, so this is the included angle, which is the angle between the two sides that I have. So the included angle in this scenario is here. So if I know this angle is minus 30, I know two consecutive angles on a parallelogram are supplementary. So I know this angle is going to be 180 degrees minus 30 degrees. So I know this angle is going to be 150 degrees. So using the law of cosines, I'm going to say r squared equals 20 squared plus 10 squared minus 2 times 20 times 10 times the cosine of 150 degrees. So So I'm looking for r, not r squared, so I still have to remember to take the square root of both sides. And then since I'm in degrees, I need to make sure my calculator is in degree mode. And rounding 3 decimal places, I get my resultant vector is 29.093 newtons. This is my magnitude. Okay, so I got one answer. Now I want to find my direction. So I'm going to use the law of sines, and I'm going to find the angle by the origin. I want this angle here. So I know the sine of the angle divided by the side equals the sine of another angle divided by the side. So I know the resultant vector, so I know I have 29.093, and that angle across from it is 150 degrees, so sine of 150 degrees equals the side across the angle I'm looking for is 10 newtons divided by the sine of the angle I'm trying to find. So I know I'm trying to find an angle, so that's going to be a sine inverse. So theta is sine inverse, and I know I'm multiplying these two together, which is 10 times the sine of 150 degrees divided by 29.093. So this is all in parentheses. This works the best in your calculator in fraction mode. So I get the angle is 10 degrees. But since I'm going in the negative rotation, my direction is negative 10 degrees. Okay, so when I was finding the law of sines, it doesn't tell me the direction. It just tells me what the angle is. So I need to make sure I interpret the information. Okay, so that is an example using the parallelogram or oblique triangle method. So I draw my two forces, then I draw them tip to tail to make a parallelogram. I draw in my resultant force, and then I solve for the resultant force, and then the angle, the specific angle I'm looking for. All right, let's try a vector method now. Okay, two forces with magnitudes of 400 pounds and 300 pounds act on an object at angles of 25 degrees and 70 degrees respectively, with the positive x-axis. Find the direction and magnitude of the resultant of these forces with respect to the x-axis. Okay, so I'm going to draw these two forces on two separate diagrams. So one of them is 400 pounds at 25 degrees. So this is 400 at 25 degrees. And the second one is 300 at 70 degrees. So 300 it's hard to see, I'm sorry. 300 at 70 degrees. Okay. So I want to break these down into the x and y components. And the formulas I use for these are x is r times the cosine of theta, y is r times the sine of theta. So I'm going to break each vector down. So the x coordinate is x is 400 cosine of 25 degrees. And the y component is 400 times the sine of 25 degrees. And for my second vector, it's going to be 300 times the cosine of 70 degrees and 300 times the sine of 70 degrees. So I know I can add my horizontal component to my horizontal component and my vertical component to my vertical component. So my resultant vector, I get 465.129, and my vertical component, I get 450.955. So I'm drawing a new diagram. So this is going to look like this. So 465.129, tip to tail, 450.955, and then here's my resultant vector and my angle. So now I am going to use the other two vector formulas. So R is really the hypotenuse of the right triangle, so I'm applying the Pythagorean theorem essentially, and then to find the angle, it's the tangent inverse of y divided by x. Okay, so the resultant vector is going to be the square root of 465.129 squared plus 450.955 squared, and then I'm taking the square root, so I get 647.847 pounds. The force I'm using is in pounds. This is the magnitude. And then my angle. So theta is the tangent inverse of y divided by x. So y is 450.955 and x is 465.129. So tangent inverse. So 44 degrees, and this is my direction. Here we go. So we have one of each. Okay, next we're going to talk about some real world vocabulary associated with planes. So I have a separate diagram here. So the airspeed is the resultant vector. So that is what my airplane's speed is. So that's called airspeed. So when we are talking about airplanes and crosswinds, we're using compass directions. So I measure from north, and positive direction is clockwise. What else? Got some more directions down here. I'll explain as we're going through the examples. So let's go through these couple examples. Okay, a plane is flying south at an airspeed of 100 kilometers per hour with 25 kilometers per hour tailwind. Find the ground speed, which is the resultant velocity of the plane. Okay, so I'm going to sketch in a compass. So north, south, east, and west. Okay, so when a plane is flying at an airspeed of 100 miles per hour, so I'm flying south. So I know, since I'm flying south, I am going 100 miles per hour. kilometers per hour. So 100 kilometers per hour here. With a 25 kilometer per hour tailwind. So tailwind means the wind is the same direction as the object, okay? Okay, so anytime I'm using the word tailwind, so since I'm doing tip to tail, so the tailwind is 25 kilometers per hour. So my resultant vector is from the initial point to the last tip. So here's my resultant vector. So since they're both going south, this is going to be 100 plus 25. So it's 125 kilometers per hour is the ground speed, is what we call that. So the resultant vector is called the ground speed. Okay, let's try another one with a little bit different vocabulary. Okay, a plane is flying south at an airspeed of 100 kilometers per hour. So north, south, east, and west. So I am flying south at 100 kilometers per hour. And a 25 mile an hour headwind. Let's see. 25 mile an hour headwind. So when I have a headwind, that means the wind that is against the opposite or against. Okay, so it's 180 degrees the opposite direction. So this from tip to tail, so it means I am going to go 25 in this direction. So my resultant vector is going to be at the initial to the final. So here's my resultant. So my resultant vector is going to be 100 minus 25. So 75 kilometers per hour. And this is the ground speed again. We got quite a bit new vocabulary. So airspeed is the speed of the object. Ground speed is the resultant vector. Headwind means the wind is opposite the direction of the object. And tailwind means the wind is the same direction as the object. All right. One more. Last one. Okay, a plane with a heading of 130 degrees from north and an airspeed of 100 kilometers per hour encounters a wind speed of 25 miles per hour from the west. Find the ground speed and the course of the resultant and the course of the plane. All right, so again, I'm going to draw. So we've got north, south, east, and west. So I'm heading 130 degrees from north. So 130 degrees from north is 90 degrees plus 40 degrees. So north is 0 degrees. So here's 90. So here is 40 degrees. Okay, and I'm going 100 kilometers per hour. and encounters a wind of 25 kilometers per hour from the west. So if it is from the west, that means it is going east. So from the west is going east. So this is 25 miles per hour. Okay. Okay, so I'm going to draw these tip to tail again. So I got this one this way. This one is 100. 25. Drawing in my resultant vector here. Here we go. So this is resultant vector. Okay, so I want to solve using the law of cosines. So my resultant squared is going to be 25 squared plus 100 squared minus 2 times 25 times 100. Now this is 40 degrees, so this is going to be 180 minus 40. So this angle is 140 degrees, so times the cosine of 140 degrees. I want to solve for r, so I'm going to take the square root. So r is 120.229 kilometers per hour. This is the ground speed, which is the magnitude. Okay. Next, I want to find the angle. So the angle I want to find is the angle by the origin here. So I'm going to use the law of sines. So I'm going to use the resultant vector over the sine of the angle. So 120.229 over the sine of the opposite angle, which is 140 degrees. And then I know 100 and the angle I'm looking for are related. So I want 100 divided by the sine of theta. So I'm looking for an angle, so that's going to be sine inverse. And I'm solving for multiplying 10 times the sine of 140 degrees divided by 100.229. So I get the angle is 32.319 degrees. Okay, so now the question is specifically asking me for the course. So the course is from north. So this is the direction from north. So this is 32 degrees in the negative direction, so I'm going to add 90. So the course is going to be 90 plus 32.319, which is going to be 122.319 degrees from north. So make sure you answer the question. Okay, we're done.